assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
This problem involves a simple pendulum that has a length of L, which we are trying to find, and a bob that has a mass of 0.2 kilograms. And we're given a graph that represents the angle at which the bob is off from the vertical, as well as the amount of total kinetic energy. Now, obviously, as the bob gets closer to the center, the kinetic energy is at its greatest, and potential energy is at zero. And as it goes and swings back up towards either side, the kinetic energy becomes zero, and the potential energy becomes at its highest. And because of the conservation of energy, our kinetic max is going to be equal to our potential max because energy is conserved through the motion. Now, we can use the equation that potential energy equals the mass times gravity times the length of the bob times 1 minus cosine of theta, because at any given point we can use that equation to figure out what the potential energy is. And we can figure that our maximum potential energy is going to be mass times gravity times the length of the bob times 1 minus cosine of our theta max here. And since we have up here that K max equals U max, we can actually make that our potential max equals mass times gravity times the length of the bob times 1 minus cosine of our theta max as well. From the graph, reading the graph, we get that our potential or our kinetic max is equal to 1.5 times 10 to the negative 2 joules, because in the graph here, if this is 10, then this is going to be 15. And we can also get our max theta, which is going to be 100 microrads as well. So, coming back down here, we have that our K max is 1.5 times 10 to the negative 2 joules. We know the mass of our bob, we know gravity, and we know that our theta max is going to be 0.100 rads. So we can plug those values into our equation up here. But we want to solve for L. So what's easier is to go ahead and we can rearrange this equation, solving for L, which would give us the length of the bob is equal to our kinetic max divided by mass times gravity times 1 minus cosine of our theta max. And plugging our numbers in, we get L equals 1.5 times 10 to the negative 2 joules divided by 0.2 kilograms times 9.8 meters per second squared times 1 minus cosine of 0.100 rad, and that gives us a length for our bob. The string that our bob is attached to has a length of 1.532 meters.